Hi and Assalamualaikum. Welcome to our video presentation. Today we are going to share to you guys about queuing system. So the topic that we choose for this queuing system are pump at Petron Tapa. So stay tuned and hope you guys enjoy our video. Before we going further into the video, let me introduce to you my group members. So the first one are Fidaus bin Ahmad Zaidi. The second one, Mio Aiman Hafiz bin Mio Arifin. The third one, me, Muhammad Hazim bin Muhammad Kamael. Next, Muhammad Hazmi Haris bin Zakaria, and lastly, Muhammad Nur Taufik bin Abdul Razak. In this video presentation, we are going to touch on introduction, characteristic of queuing system, and lastly, conclusion. Now let's jump to the introduction. Petron Tapa Road are located at KM8, Tapa RD, Kampung Baru 5, 35400 Tapa Road, Perak. Operating hours for this pump station are 24 hours, and the number of pumps that have in this pump station are 7, but we are only choosing one pump, that is pump number 4. Next, we are going to show to you the photo and video of service center building Tapa Road, Petron Tapa Road, and customer and the waiting line. So let's go to the video.
Okay, for the characteristic of one pump at Petron Tapa queuing systems, there's 3 characteristics, such as arrival characteristic, waiting line, and service facility characteristic. For the arrival characteristic, the size of calling population is unlimited or infinite. It means that the number of customers being served and waiting in the system is not affected by the arrival rate. Next is the behavior of the arrival, that is patient customer. The customer wait in the queue until they are served. The pattern of the arrival at the systems followed by the Poisson distributions with lambda equal to 20 customer per hour. Next is the waiting line characteristic. The length of the line is unlimited. It means that there's no specific number of a customer at pump. For the queue disciplines is first in, first out. In other words, the customer who arrive first will exit the Petron Tapa first. Lastly is the service facility characteristic. The service facility usually classified in terms of number of channel and number of faces. For the configurations of the service facility that used by Petron Tapa, for the number of channel, in these cases, is a single channel systems. It means that there's only one counter. For the number of faces, is multi-phase systems. That is implies 2 stops or stations before leaving the Petron Tapa. For the pattern of the service times, assumptions of service times followed by exponential distributions with mu equal to 30 customer per hour.
Next, I will talk about the characteristic of the service facility. As we know, there are many pumps provided in a gas station, but for this study, we only observe one pump, which is a single server. The number of queues in the system is a single line system. Next, the basic queuing system configuration in a single server, which is one counter only. The customer will arrive and they will make a payment. Then, they will queue in a single line to make a payment at the cashier. After that, they will go to the pump to refill their vehicles. After finish the process of oil filling, they will exit the Petron pump station.
We
talk about the calculation about queuing system for our observation, where the arrival is 20 customer per hour and the service rate is 30 customer per hour, with the number of server is equal to 1. For the average number of customer in the system, we substitute lambda mu into the formula. We got 2. Meanwhile, for average number of customer in the queue, where the formula lambda must be powered to 2 and divided to mu times mu minus lambda, we got to 1.33. The average time customer spend in the system is 1 over 10 hour, which is equal to 6 minutes, and the average time customer spend in the queue, we got 1 over 15 hour, which is equivalent to 4 minutes, and then utilization factor we got probability is equal to 0.67. When we complete 1 minus probability that service system is busy, we will obtain the value of probability of no customer in system, which is 0.33.
Alright, right now I will show you how to solve queuing system by using QM4 window. Firstly, open the QM4 window. You will see the choice under module 3, and then select the waiting line and click on m/m/1, which is exponential service, because our queuing system is a single channel. And then put on the title. We will name this title as queuing system at petrol pump. And then for cost analysis, click on no cost and click OK. So next is we will enter the value. For lambda is 20, service rate, which is mu, is 30, and number of server is 1. Okay, for time unit, we will use hours, and then we click on solve to get the final answer, final result. So as you can see here, the average server utilization is 0.63. Average number in the queue, which is LQ, is 1.33. Average number in the system, which is L, is 2. Average time in the queue, WQ, is 0.07, and average time in the system, which is W, is 0.1. Alright, for my part, I will present about conclusion. What we get from the group project. Alright, for the first one, is the number of server provide adequate? So the number of server provide is adequate because the customer waiting time is less than the arrival time. Next is, are the customers happy with the waiting time? Yes, they are happy because they do not need to wait long before being served. What have we learned from this project? So the first one is we gain experience on how the waiting system happen in real life. We learned that good server will lead to a decrease in waiting time. It is because the arrival rate is less than the service rate.